Hello guys, this is lesson 13. This one just takes a little bit to just keep doing it and get the different names. Some of them are common names, some of them are systematic names, so it's good to just go through it and have your notebook and write down what everything else is. So let's start with this Floral Benzene. These aren't too bad when you get like the chlorines and the bromines. Those are probably the best ones in this lesson. So I drew my ring. It's a benzene ring, so I'm going to have a bunch of double bonds. I'm going to add a double bond there, put a double bond over here, and then also right here. Doesn't really matter where you're going to add your fluorine. Either way, it's going to be surrounded by double bonds, or like one double bond on one side and the other one with a single bond. So I think that was fluorine. Yeah, I don't remember it being pink. I really don't remember it at all. I don't know if we've used fluorine. Okay, that's it. I think we're going to be counting our cyclic pi electrons. Yeah. So we're just going to count each of these blue lines. So 1, 2, 3, 4, and then 5 and 6. So 6. Okay, we're naming. And I've gone through this lesson a lot. I have like my notebook on here, but I'll try to explain some things. If you haven't watched his video yet, he does give a lot of examples, so I do recommend you watching that. First, we're going to see that we have one functional group at the 1 position and then another functional group at the 2 position, which means that this molecule is ortho. So whenever you have one at 1 and one at 2, it's ortho. If you had one at 1 and then a functional group at 3, and that would be meta, or also M dash. And then if you had it at the 4 position and the 1 position, that would be para, or P dash. So we have this, we have our carboxylic acid, we have an OH group over here. So I've got a lot of different names, but I'm going to name it ortho hydroxy benzoic acid. You could also put the 1 and 2 instead of ortho, but I like putting the ortho because that just indicates that it's 1 and 2 already. And then let's see, it looks good. I'm always iffy that I'm forgetting like one letter, but we'll see. Okay. So again, watching his video, it really does make sense when he explains like the different positions of the functional groups. Okay, we got a good one, or an easy one I should say. We've got the bromine and the benzene. So we're just gonna name it bromobenzene. And let me check my notes because I always want to double check. Bromobenzene, yeah, it looks right. And then we're gonna do our cyclic pi electrons. I'm gonna count, oh, I guess we're not. If we did, there would be 6. I guess only with the drawing ones we're doing the cyclic pi electrons. Okay, awesome. We got this big one. This one actually has another name that's way easier. So if you ever have to name it, you just name it like this. S Naproxen. So it's way easier to name than this huge thing. So first, we're going to take our time on this one because we got to make sure that all the elements are right. So I'll add 1 benzene ring. I'll do a double bond down here. I'll add my other double bond so I don't forget. And then I'm going to add another ring over here. I'm going to make sure it has 6. So 1, 2, 3, 4, 5, and 6. I'll add my double bonds already. I'm going to arrange it just so I can get like a better picture of it. And what we're going to do is we're going to add all this extra stuff to it. So I'm going to get my oxygen out. And at the 2 position, 1, 2, I'm going to go ahead and put my oxygen. And then I'm going to add a methyl to the bottom of it. Okay, and then I'm going to go 2, 3, 4, 5, 6. I'm going to come over here and add an ethyl, and then add this carboxylic acid to that. Oops, okay, double bonded O. This one's really big, so it's hard to fit all of it in the canvas at once. I'm going to add my hydrogens now. And lastly, we're going to look for the chiral center because it is indicating that we have an S chiral center. I see it right here, so I'm going to go ahead and turn it around so my lowest priority is in the back, and what I get is what I get. I don't have to flip it around. So I've got my highest priority down here, my second priority up here, and then my methyl my third. So it's going right there to the right, so this is actually our conformation. And I'll go ahead and mirror that. Okay, and it might look like this is the highest priority because you have like all this junk going on, but when you really think about it, once you go out one bond, so you get these carbons, but then you go out one more, you got 2 oxygens, compared to over here where you only have 2 carbons. So that's why this is higher priority. But yes, I will leave it at that. It's so big, so it's easy to miss like a one component, but I'll go ahead and try it out. Okay, and then we're gonna go ahead and count those double lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Got 10. Awesome. So just take your time on this one. Make sure that you're getting everything right. Don't forget double bonds. Don't forget any of that. Phenyl methanol. So this one's pretty straightforward. Oh, I did not draw that the way I wanted to draw it. But I'm going to add my double bonds. And it's just a methanol, so all I have to do is add the methyl and the oxygen. And I'm actually going to look at my notes because I don't have it. So I'm going to add that. I'm adding an alcohol, so this should be it. And then I have a page open down here. So what I usually do in this homework, just to get extra practice, is that I draw first, and then I pull up my little thing here, and I type phenylmethanol after I've already drawn what I think it is, just to get confirmation and see if I'm doing it the right way or where I went wrong. So we go here, pub chem, and this is awesome. So it's just looks like I got it right. Got my methyl with my oxygen attached, my alcohol. So this should be good to go. I think I have all my double bonds in place. So I'm going to go ahead and submit it. We've got 6. You can always just count and just multiply by 2. So 1, 2, 3, and then that gives you 6. Or you can just count manually 1, 2, 3, 4, 5, 6. And I'm going to write this in my notebook. No, I don't have it. Okay, I'll draw this later and write it. Okay. Okay, so this one is, it looks like ortho hydroxybenzoic acid. And I wrote that the first time, but if you noticed, ortho hydroxybenzoic acid has an OH at the end, and this has a methyl hanging off that O. So this is actually, I'm going to put it by its common name. It's called wintergreen. So that one's gotten me a few times. So really make sure when you're looking at your oxygens that you're looking if they're connected to hydrogens or methyls, because sometimes those methyls can be a little sneaky. Okay, phenylethanone. So I know by ethanone that we're gonna have a ketone. I'm gonna draw this, and if you see here, I'm gonna add my double bonds. And say I was to try to do a double bond here, anywhere on this molecule, it wouldn't be possible because any carbon that I try to add another bond to would end up with 5 bonds. So this is an indicator that we're actually going to have, we're going to connect a carbon like this. So we have the ethyl, and then we're going to add our double bonded oxygen. Add our hydrogens. So that gives us that ketone that we're looking for. And of course, I'm going to go to my notes again just to double check. But it looks right. Yeah. So you just want to make sure you have that ketone. If it said diphenyl, then we would add another 6-member ring on this side and keep that ketone. We've got 6 cyclic pi electrons. So this is something that I don't think I have this one, so I'm going to look it up because I might have it, but I might have the systematic name, and I haven't come across the common name yet. So I'll look up acetaminophen structure. And then my handy dandy PubChem. This is the one that I trust the most, and I love using it. So let's look at this one. Let's see. And now I'm going to look at my notes and see if I have anything like that. I think that is the hydroxy, like benzyl amide or something, amide. I don't have it in my notes, but I know I got one like it. So let's see, I'm going to go ahead. Or I do have one like that in my other notes in my wrong notebook. So it looks like it's N-4 hydroxyphenyl ethamide, something like that. It's para. So I know that the nitrogen and the oxygen will be on the opposite sides. And I'm going to go ahead and draw this. I'm just making sure that it's the right one before I start drawing. Okay, so I'm going to draw my ring. I said it's going to be para, but let me add those double bonds. Okay, let me get my nitrogen, and I'll add it here. And then I'll get my oxygen, and I'll add it para. So one's at the 1 position, one's at the 4 position. I'll switch to my carbons, and I know there's going to be an amide, so I'm going to add a carbon, and then another carbon, and a double bonded oxygen. I'm going to go back here and make sure that that looks about right. Looks pretty good to me. Actually, what I'm going to do is add my hydrogens, hit arrange and fit, and then I'm just going to count those carbons just to make sure, because sometimes it gets a little messy. 1, 2, and then another 6, there should be 8 carbons. So 6 here, 7, 8. So yeah, I think it looks about right. Let's see. We've got 6. I don't count this one because we're only counting the cyclic pi electrons, so the ones in the ring. Awesome. And let me go ahead and draw and type that name in case you come across it. It's 4-hydroxy phenyl parentheses ethanamide. I think, yes. Ethanide. Mine says ethanide. I don't know. I scribble on my notebook, so it's kind of hard to tell sometimes, but it should be something like this. Okay, and then I'm just going to draw or write the name really quick, just so I have it. Acetaminophen. Okay, let me zoom out because I can't really see it. So I think this is the same one we had earlier with, did we have it earlier? The Ortho. So I'm gonna start by typing Ortho. So I don't want to do the 1 and 2. You can do the 1 and 2 if you want to, but I don't want to. I'll do hydroxy benzoic acid. And we've got the benzoic acid because we have carboxylic acid here. We have our hydroxy down here. And then ortho just means 1 and 2. If this was over here, we could put para-hydroxy benzoic acid. If it was here, we could put meta. If it was here, we could put meta. If it was here on the 4 position adjacent to that, we could put meta or M. Para. So I'll put it here because I'm probably confusing people. Ortho, we have para, and we have meta. So these are the 3 things that we have. Para is adjacent, meta is 1 and 3 functional groups at those points, and then ortho is 1 and 2. Let me make sure I delete this before I turn it in. And then I'm just going to double check, make sure everything looks right, but it looks about right. Okay. Okay, and this is what I was talking about when you have a ketone and it's a diphenyl. So you've got your ketone right here in the middle with 2 phenyl groups attached, or benzene rings. And there's several names. I'm going to try this name because I think this is the one he got in his video that he showed us. And then I'm going to go ahead and look it up too, just to do it. So I'll put benzophenone. Okay, so that gives me validation that it's in the right direction. So benzophenone, and I'm going to go ahead and submit. Okay, so definitely have like a little box here, a web page where you can look some stuff up, but I suggest trying it first so you can see kind of like where you went wrong in case it gets wrong. And then of course having your notebook and writing down the common names, systematic names, anything associated with a specific molecule or that. So yeah, that's all I have for today, and good luck.